Hi, my name is Rena Plegemeyer, and I'm doing a teaching video clip on how to derive y equals mx plus b using similar triangles. The first thing that we're going to discuss is what content standards this addresses. It addresses 8.EE6, and that standard simply states that students need to understand the connections between purportable relationships, lines, and linear equations. It also states that using similar triangles to explain why slope m is the same distance between any two distinct points on a non-vertical line in a coordinate plane. So on the same plane, not a 3D, 1D. This derives the equation y equals mx for the line through the origin and the equation y equals mx plus b for the line intersecting the constant axis at b. So finding the slope of a line using triangles. So what is the slope? The slope of a line describes the steepness, the incline, or grade. The higher slope value indicates a steeper incline. The slope is described by the ratio, which is a constant, never changing, which is rise divided by the run. So x over y between the 2 points on a line. So to start out, we're going to start out with an example so that you can better see what rise over run means, and then we'll go from there. So on this little grid, your rise is going to be this, whereas your run is on your vertical axis. So rise is on your horizontal, whereas run is vertical. Okay. So now we're going to break down what y equals mx plus b means. So y and x are your points on your line. So, and then your m is going to be the slope, which is always constant. And then b is where it intersects the y axis. So with an example here, if you have a line, a constant line, never changing line, and you have two triangles on that line, and one is 6 and 4 and the other one is 9 and 6, right here. So 9 and 4, 6 and 4, and 9 and 6. Notice that the rise and run are essentially the same ratio. So if you have 6 and 4, which is equal to 9 and 6, you can simplify that down and it'll be equal 2 over 3. So the slope of this line, even though the triangles are different with different numbers, they equal 3 over 2. Okay, so moving on from there, we're going to start with a line on a plane. So if we have a point on this line, just one point, and we can say that that point, you're told that that line passes through point 0 and 4. So that point right there, that dot, passes through 0, 4. So you have no run, which is 0, and your rise is 4. So you have a run. Okay, yeah. And then you are told that that slope of that line is 2 over 3. So you have a triangle up here that equals 2 over 3. So you have a triangle right there that equals 2 over 3. So that fits right there. So no matter where on that line, you're always every point, no matter what the difference between them, the two are, the slope is always going to be 2 over 3. So the next step is to find, so if you know, we know this right here, the rise is 4. But where this little line comes down here, that is a question mark. Right there, do you see that question mark? Okay, so we have 2 triangles. We have the smaller triangle that is 2 over 3, and then we have this larger triangle that we're looking for to find that point. So we have y minus 4, because we're deriving that from the equation y equals mx. So we have y minus 4 as the run and x on the top. So what we want to do is to equal those out. So we want to create the equation of, we're going to erase these 2 triangles here so we have more room to work. We want the equation to equal, so y minus 4 over x is equal to 2 over 3. So now we want to multiply by x and add 4 to both sides to get the x out of the bottom and have a workable equation. So if we multiply by x, that gets rid of that on the bottom. We x'd out the x. Maybe we should scribble it out. We got rid of the x, so we have y minus 4 equals 2/3 x. Now we need to add 4 to both sides. So if we add 4 here, if we add 4 on that side, we are going to get rid of the minus 4. If we add 4 on this side, we end up with the linear equation y equals mx plus b, which in this case it's y equals 2/3 x plus 4. So if we know x is 0, any point on the x-axis, so you plug in y, so your rise on the y-axis and your x-axis, you can plot any point along that line using these triangles.